Alright, so this is the video for those of you that did not freaking do your homework. So, you need to focus. Go to this page in your notes. This page right here, the yellow one. This one has everything you're going to need in order to do the practice. Now, I'm going to go over the 5 problems at the bottom of your practice, and then we're going to go over how to read the chart and how to use the chart in order to do it. You're going to have a quiz today or tomorrow, so you need to figure out how to do it. So, looking at the first one, ionic bonding. These are intermolecular forces that occur here. There's only one that's not on here, and that's metallic. Metallic is just a metal. But an ionic bond is a metal and a nonmetal. Make sure on your graph, in your notes, it says metal and nonmetal. Okay? Next, if I have a metal and a nonmetal, that'll be ionic bonding, and we'll label it as ionic. This one's pretty strong. As you can see, it's the strongest one of the 6 that are on here. If there's 2 of them that are ionic bonding, then we look at the charge, like on the periodic table, +1, +2, +3, -1. If the bigger the charge is, the stronger it is, or if it's smaller, then it's stronger. For it to be ion dipole, I have to have 2 different things, ionic and polar. The key word here is the and. It'll say like salt and water. It'll have multiple things in there for it to be an ion dipole. For hydrogen bonding, I need to have H bonded with N, O, or F. One of the 3 elements. So if it's H bonded with N, it's hydrogen bonding. If it's H bonded with O, hydrogen bonding. If it's H bonded with F, hydrogen bonding. Dipole. The word dipole means polar. So if it's just a single polar molecule, you draw it out and it's polar because it has dots on it, or there's different elements around it, it's polar, it's dipole. Dipole-induced dipole, that means I have a polar and a nonpolar. And then the last one is London dispersion forces. London dispersion is just nonpolar. So make sure you have all these things written here. The parts I wrote in black. Make sure you have those written down in your notes because you need them. So nonpolar is when it's surrounded by the same elements. It'll be London dispersion. And if both of them are London dispersion, how can I pick which one is stronger out of the 2? Whichever one has the most electrons. Okay? Alright, so going to your practice here. I'm going to do the bottom 5 just to show you how it goes. Okay? MgCl2. First, MgCl2, we have to look on the periodic table. If you look, Mg is on the left side of the periodic table, whereas Cl is on the right side. So I have a metal and a nonmetal. So right below it, like this, hold on, I'll put MgCl2. So there's my example. Okay, that's your example that you have on your paper. All right, so right underneath the Mg, I'm going to write a little M because it's a metal. And then right below it, I'm going to write an Nm because it's a nonmetal. So if I look back at my notes to this chart right here, metal and nonmetal is an ionic bond. So if I go back to the practice here, MgCl2 is ionic. And I'll write ionic in that box right there, ionic. That's the intermolecular force that's holding the Mg with the Cl. All right. Next, I have BaCl2. So BaCl2. Again, find it on the periodic table. Ba is on the left, Cl is on the right. I have a metal and a nonmetal. That's ionic again. So they are both ionic. I have MgCl2. Here, let me flip them. I have MgCl2, which is ionic. And I have BaCl2, which is also ionic. So they're both ionic. So how can I figure out which one is stronger? Because that's the 3rd box over here. This 3rd box right here, that's you have to tell me which one is stronger. So if I go back to my chart, since they're both ionic, I have to look at the charges. Mg is a +2, because it says it on the periodic table. If you look up there, Mg, right above it's +2. Cl is -1. Ba is also +2. Cl is -1. So they have the same charges. So then next I have to look at the size. Since the arrow is going down, I want the one that has the smaller size. That one's going to be stronger. So if I look at the periodic table, Mg is above Ba. So Mg is smaller. So Mg is the smaller molecule. Since it is smaller, MgCl2 is stronger out of the 2. So I would put MgCl2 in the last box. Because it's the smaller one, it's the stronger one. Next problem. SbBr3. Okay, this one I need a real periodic table. Give me a second. Okay. Here we go. SB. SB is right here on the periodic table. If you look, it is on the left side of that zigzag line. You see it? So there's a little zigzag line. It's on the left side. Since it's on the left side, we're going to call that a metal then. So SbBr2. This is a metal and a non-metal. From our chart, we saw a metal and a metal is ionic. Done. Next, I have CbR4. CbR4. If you're unsure, look on the periodic table. Carbon is not a metal. Carbon is a non-metal, so you have to draw it out. If it's a non-metal, you always draw it. Carbon, Br. It looks like carbon's in the middle and it's surrounded by Brs. Let me count up the valence electrons. Carbon is 4 plus 7 times 4. That's 28, 32. I've used 8. I have 24 left. Carbon already has 8, so it's good. All the Brs are going to get 6. So looking at this picture here, this is nonpolar, NP. Because this carbon is surrounded by the same element. If it's surrounded by the same element, I'm going to call that nonpolar. So if I go back to my chart, since it's only nonpolar, it must be this one over here because it says nonpolar right there. London dispersion forces. And so in this box right here, where it says CbR4 right next to it, I'm going to write London dispersion forces, or I'll just put LDF to shorten it. LDF. And now I have to pick which one is stronger, ionic or London dispersion. So if I go back to the list, ionic is up here, London dispersion is down here. Ionic is going to be stronger than of the two. So then I will say SbBr2 is the stronger intermolecular force. Okay, and that's what you should write down on your paper. Let's try another one. Br2 and C8H18. Br2 first. Br2. Br2 is not a metal, so you have to draw it. Br bonded with Br. As you look, they're the same element. So since they're the same element, one's not going to be positive, one's not going to be negative. This is non-polar. I don't even need to finish drawing it because it's the same element. Since it's non-polar, going back to my list, non-polar right here, London dispersion forces. LDF. Next I have C8H18. If you ever have any carbons and any hydrogens, ever, that is always London dispersion. But if there's another element, then it changes it. So if there's an O in there, then it is not London dispersion. But only if it's carbon and hydrogen, it's always going to be London dispersion. Always. So there's two London dispersions here. Now I have to figure out which one is stronger out of the two. So if I go back to my chart, if they're both London dispersion, I want the one that has the bigger number of electrons. Whichever has the most electrons is the strongest one. So going here, how can I figure out electrons? Just look on the periodic table. Br2 is number 35. And there's two of them, so times 2 gives me 70 electrons. C8H18, carbon is number 6 on the periodic table, and there's 8 of them. Hydrogen is 1, and there's 18 of them. So let me add that up. What is that? 48, 56, 66. 66 electrons for this one. So as you can see, Br2 has more electrons. That one's stronger than C8H18 with only 66 electrons. So Br2 is the answer for this one. Okay. Next. KCN. KCN. Look on the periodic table. K is a metal. Carbon and nitrogen are both nonmetals. I have a metal and nonmetal from the chart. Must be ionic. Next, I have NH3. This is not a metal, so I have to draw it. N, H, H, H. If I count up the electrons, I should have 8. Minus 6 because of the bonds gives me 2. The nitrogen still needs 2, so I'm going to put 2 dots on it. Just like that. This one is special. If you look at it, N is bonded with H. Let's go back to my list. N is bonded with H. This must be hydrogen bonding because N is bonded with H. So in this box right here, I'm going to write HB for hydrogen bonding. Just like that. Which one is stronger, ionic or hydrogen bonding? Well, they go in order. Ionic is the strongest, London dispersion is the weakest, so hydrogen bonding is weaker. So I'm going to write KCN in the last box because that one is the strongest of the two. Last problem. NCl3, pH3. NCl3. NCl3. N is not a metal, so I have to draw the structure. N in the middle, Cl, Cl, Cl. Count up the valence electrons. 5 plus 7 times 3. That's going to be 26. I've used 6 of them. That's 20. Chlorine needs 6, 6, 6. Nitrogen still needs 2. I have enough, that's 20. So let me put all the dots. Okay, so there's my structure. Put all the dots. If you look, N has 2 dots on it, and it has 3 bonds. Since it has those dots, this is polar. Makes it polar if there's dots on the center atom. So since it is polar, we're going to say that one is dipole-dipole forces because that one is polar. So right here in NCl3, I'm going to write dipole-dipole forces, or I can abbreviate and put DDF. Just like that. Next, I have pH3, same thing. P in the middle, 3 H's. pH3. All right, counting them up, that's 5 plus 1 times 3, that's 3, equals 8. I've used 6, that's 2 left. Only phosphorus needs more because remember, hydrogens only want the 2, so they don't want any more. So I'll put the 2 dots on phosphorus. Since the middle element has dots, it's polar. Since it's polar, since it has the dots, this is dipole-dipole forces again. Now, since they're both dipole-dipole, which one is stronger? So that's when I have to look at the chart. Let's see. If they're both dipole-dipole, I want the one that has the smaller size. That one's going to be stronger. So let's go back to this. NCl3 or pH3. So N is number 7 on the periodic table. Chlorine is number 17 on the periodic table. And there's 3 of them. Phosphorus is number 15 on the periodic table. And hydrogen is number 1 on the periodic table. And there's 3 of them. So if you look at those numbers, it looks like pH3 is going to be a lot smaller. pH3 should be the stronger dipole-dipole force then out of the 2. pH3. And so that's how you're going to do the practices. Start doing the ones above it and start going through.